Okay, let's look at integrated circuits at a very high level here. So you can see this is a chip. It's got pins on the side here. There's 7 pins on the side and 7 pins on the other side. So a 14-pin chip. Okay, it's hard to see in the video, I know, but there's a little notch on this side that tells you the orientation of the chip, so that when you're reading the documentation, what's called a data sheet or a pinout that tells you what each of these pins do, you know which direction the chip sits in. And this is a 32, shorthand is called 32. The only way you can tell what it does is by reading the name on top of the chip. Okay, and this is a 32. This is a 08. It looks exactly the same, doesn't it? Well, this is 4 OR gates, and this is 4 AND gates. Okay, so they look the same, so you got to read the top to know what they are. And that's true with any integrated circuit. In fact, you really can't tell what a chip does or how sophisticated it is unless you read the top and then go read the data sheet. So this happens to be 4 OR gates. You can see the first pin here, and the second pin here are inputs, and the third pin is the output of an OR gate. So think about the OR gate that we built with 2 transistors, right? There's a lot of wires, and for a sense of scale, here's a transistor. So you can see how our set of circuits there were completely miniaturized and put inside of this integrated circuit or IC. So this teaches us 2 concepts. The first is that we can miniaturize, well, 3 concepts really. First, we can really miniaturize our circuits with integrated circuits and make them very neat. So what we're building becomes very tidy, okay? And also there's 2 more important concepts, and that is the concept of interface and the concept of encapsulation. So the concept of interface is that all I need to know about an OR gate is the inputs and the outputs that it expects, and so the inputs that it expects and the outputs that it will provide, and I need to know what to expect on the output if I provide specific inputs. Okay, I don't need to know how it's implemented inside, okay, of this. So you have a concept of an interface, inputs and outputs, and what to expect. And you have a concept of encapsulation, in which I don't need to know how this is implemented. And that's exactly what we see on an integrated circuit, where I've got no idea what's going on inside of here, but the data sheet tells me that the first and the second pin are inputs to the first OR gate, and the third pin is the output. So the way that I read these things, let's move this out of the way for a second, is I get the pinout or data sheet for the integrated circuit, and I read about it. And in this case, the 32 says that pins 1 and 2 are the first inputs for the first OR gate, and pin 3 is the output. Okay, so I'm just going to put this alongside because this is what we're talking about. Then I have another OR gate. So pin 4 and 5 are another set of inputs to a completely different OR gate, and 6 is the output. 7 is a ground, okay? And then the pins are numbered this way from the bottom up on the other side, but you can see we have 2 additional OR gates on the other side. Pin 14 is power, so it's opposite of 7. 13 and 12 are inputs to the third OR gate. 11 is its output. 10 and 9 are the fourth set of inputs to the fourth OR gate, and 8 is the output. So once I plug this chip into my board, I've got 4 OR gates I can play with, right? So pretty cool. Now, let's put it onto our breadboard. Okay, so no big surprises here. I've got power coming into this bus over here to keep things nice and tidy. I've jumped that power over to the other side of the bus, and I've tried to create sort of an idea that my inputs are going to come from the bus on the left, and I'm going to power the IC through circuits on the bus on the right, okay? And you can see I've got three wires that really play the active part of this example. So I've got two input wires and an output in yellow going to our LED, which is how we're going to know what the output is. And right now both inputs are in ground or are in the 0 state. And now if I just plug in our integrated circuit, and the first thing I'm going to do is I'm going to look and see where the notch is on the circuit. It's over here, so I know that this is pin 1, 2, and 3. Okay, if I put that in backwards, I could get really unexpected results, or even I could even smoke the chip if I'm not careful, depending on how it's wired up inside. So what we're gonna do is I'm gonna be carefully, I don't wanna bend any of the pins, and I'm making this look hard. I'm gonna push that down, okay? And now you can see it's set in there, and I can see that pin number 7 is lined up with ground. I can see pin 14 is lined up with power. Good, 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 everything's good. So then the interesting bits, my input, my first OR gate here, which is the first 3 pins, I've got set input in 1 is in 0, input 2 is in 0, and the output is off. So now, it's an OR gate, so if I put the one of the pins in power, I'm going to get output with a 1. So if any input is 1, then the output is 1. So we can see that that's working, right? So as I move them around, I can see that works. Okay, now, interestingly, this set of AND gates, okay, on this 08 chip are laid out exactly the same, okay? It just happens to be that way. So because the interface is the same and the rest of my circuits here expect the same sort of interface. If I want to play with an AND gate, I just need 2 inputs and an output. In fact, I can actually just take this 32 off and put this 08 on the board because they have similar interfaces, although completely different behaviors. Then you can see when both inputs are low, then our output is low. If we make one of our inputs high, our output is still low. Hey, that's what an AND gate does. And if both of our inputs are high, then our output is high. There you go, pretty cool. So that's our introduction to integrated circuits. Now we're going to start combining these integrated circuits. So we're going to create interesting capabilities. Like we're going to create an adder. So we're going to be able to add binary numbers. So we'll start with a half adder and we'll create a full adder. We may go on to demonstrate memory and do some other things here. But by using these integrated circuits, we're going to really be able to clean up and simplify our board. And because we've built what's inside of here, we now know how this works, and we can start to leverage this abstraction to create more interesting circuits in the same amount of space.